Hello students, welcome to AriserTalent. I'm Arpita Sharma, your maths teacher. Okay, so we were discussing some questions in last session. Okay, so I've given you this one. Use Euclid's division lemma to show that the cube of any positive integer is the form of 9m, 9m plus 1 or 9m plus 8 where m is some integer, for some integer m. Okay, let's solve this. Okay, we have proved these kind of statement before also, so we know now what we have to do. Okay, so proof. We'll be having Euclid's division lemma because the question is stating that use Euclid's division lemma. So, we will obviously use this according to Euclid's division lemma. A equals to BQ plus R, where range of R is this. Okay. Now, we have to prove this. So, what will take? We will take B as 3. So, taking B equals to 3, name it equation 1. Equation 1 can be rewrite as, write down in your notebook, A equals to 3q plus R. Now, see the question carefully. The question have asked us for a cube. So, cubing. So, question have asked the cube of any positive integer. Now, in this we have taken A as any positive integer, right? So, value of R may be either 0 or 1 or 2. As per this, putting values of R in equation, let's call this equation second. Equation second, what we will get? A equals to 3q. Now, cubing both sides, what we will get? Cube A cube, that will be equals to 9q cube, right? It can be rewrite as, implies that A cube equals to 9q cube. Okay. Now, look at this. Can we write this as 3 multiplied by 3 into q cube? And let me substitute this 3q cube as m, where m is some integer as given in question. Okay. Implies that a cube equals to 3m. That's our equation. Third, now look at this part. We'll now substitute r equals to 1. We have substituted r equals to 0. Now we will substitute r equals to 1 in the same equation, equation second. So, substituting r equals to 1 in equation second, will get a equals to 9q equals to 9q plus 1, like this. Now we will cube this, taking cube on both sides. What we will have? A cube plus, rewrite it as a cube will be equals to 3q plus 1, 3q plus 1 cube. Now, what will it become? How can we rewrite it? Implies that 3q whole cube plus 1 cube plus 3 multiplied by 3q multiplied by 1 and 3q plus 1 by our formula a plus b cube, that will be equals to nothing but a cube plus b cube plus 3ab a plus b. Okay. So, we will use this formula. Now, solving this, we will get what? A cube equals to 9q cube plus 1 plus 9q 3q plus 1. Again, a cube implies that a cube equals to 9q cube plus, I am putting this equation here. Okay. So, it will be 9 multiplied by 3 q square plus 9 q. Okay. Now, look at the question. 9m plus 1. You have to short it out in the form of 9m plus 1 to prove this. Okay. So, and here 1 is remaining. We will write 1 here. Now, a cube will become 9 is common here. So, taking 9 as common, q cube plus 3q square plus q plus 1. Now, look, if we substitute q cube plus 3q square plus q as m, then what will it become? A cube equals to 9m plus 1. Okay. So, substituting q cube plus 3q square plus q equals to m, will get what? Note this part. I'll be removing this part up to here. Okay. Now, by substituting this particular equation will become a cube equals to 9m plus 1. Okay, this is our equation 4th. Now, note this also. I'll be removing this. I'll be lefting only this equation. Okay, for conclusion. Okay, so now you all know what's the next step. Substituting. Now putting r equals to what? 2 in equation. Second, what will get? Equation was, I am writing that here, a equals to 3q plus r. Okay, so it will become a equals to 3q plus 2, right? Cubing both sides. Cubing both sides. A cube will be equals to 3q plus 2 whole cube. Now we'll solve it. That will become what? I have written your formula here, a cube plus b cube. So a cube is 3q cube 2 cube plus 3ab. 3 a is 3q and b is 2 bracket 3q, that is a plus b 2. Okay, now solve it. That will become a cube. Now what will this become? 3q cube, that will become 3 multiplied by 3 multiplied by 3 multiplied by cube, that will be 9, that will be 27. Okay, 27 q cube. Like that, 2 to the power 3 will become 8 plus now 9 q multiply by 2 multiply by 3 6 and q 6q. We'll put one plus sign here. We will put plus sign here. Now 3q again 9q 2 is 4 multiply by 4. Okay. Now again solving it, it will become a cube and I am taking this right there. Look at our question. Last one is 9m plus 8. So we have to take 8 separately and somehow convert the whole equation such that we have 9m form. How can this be possible? Look here carefully. We will taking 9 out of this equation and remainings are 3q okay, this is cube. Okay, 27 and q cube, right? So 3q square plus I am not taking this 8. We will write this 8 in the last of the equation. This will be 3q cube, then 9 will be here. So 6q square plus 4. Now this plus 8, write it here, 8, okay. Now 8 cube will become 9m plus 8. If we put 3q cube plus 6q square plus 4 equals to m, where m is some integer. Now we will call it equation what? That was 4th, so 5th, right? Now by equation 3rd, 4th and 5th, we can say that a cube, where a is some positive integer, we have taken it in this form, like we have taken it in this form, okay. So its cube will be either 9m, in the first one it was so now cubing both sides we get a cube equals to a q whole cube. Now that will become 3 raised to power 3 will become 27 and that will be q cube. Now look at the question, we have to write it in the form of 9m, okay. So can we write this? We can write this equation as taking 9 common, now what we will do, we will just take 3q cube as m, where m is some integer. Now 3 is integer, q is integer, so q cube will also be integer and the multiplication of two integers is also an integer. So 3 m cube is an integer, so we can write this as m, okay. Equation so it implies that a cube can be written as 3m so a cube can be written as 9m as required here, okay. Now I am rubbing this part, note it. So we are having our second equation, that is third equation, equation number 3rd here. Now we are having that one equation here, a equals to b q plus r equals to 3q plus r. We will use this equation again, putting r equals to 1, what will we get? A equals to 3q plus 1. Now cubing both sides, it will become what? A cube will be equals to 3q plus 1 whole cube. Now as we know the formula, a plus b whole cube will equals to a cube and plus b cube plus 3ab multiplied by a plus b. So we will apply this formula here, 3q cube plus 1 cube is eventually 1 plus 3 multiplied by 3q multiplied by 1 and 3q plus 1. Okay. Now, again solving it, a cube will become, that is 27 q cube plus 1. Now, 9 multiply by 3q plus, that will become 3q, right? That's square. Okay. We was having 3q plus 1. We cubed it, 3q, that is 9q cube. Okay. Then 1 cube, 3, a plus b, that will be right. Now, again we can simplify it. We have to put it in the form of 3m plus 1. Okay. So, 27 q cube, I am taking this 3q here and sending this plus 1 here. Okay. Plus 9 multiply by, okay, we have done this thing wrong here. It will be 9q. Okay. 3 multiply by 3, that is 9, and q here multiply by 1 is 9q. So, here it will become also 9q. Okay. 27 q cube, this term 9q, this term multiply by 9 3q square, this term. Okay. Now, again looking at our form, 9m plus 1. So, we will take 9 common, then it will become 3q cube plus q plus 3q square plus 1. Now, putting 3q cube plus q, 3q square plus q equals to what? M, where m is some integer. Now, here q is integer, 3 is integer. So, 3q cube plus 3q square plus 9 will eventually become an integer, and we are having the value m as an integer. So, we can substitute it. This will implies that what? A cube equals to 9m plus 1. This is our equation 4th. Now, we have to put, now r equals to what? R equals to 2. So, putting r equals to 2, it will become a equals to 3q plus 2, cubing both sides, what it will become? A cube equals to 3q plus 2 whole cube, that will become what? 3q cube plus 2 cube as this formula plus 3ab multiply by 3q plus 2. Now, that can be rewritten as a cube equals to 27 q cube plus 8 plus 9 q multiply by 3q, then plus 9q multiply by, this is what? 2 multiply by 2. Here again multiply by 2. Okay. Now, we will rearrange it. I am lefting 8 for the very end. Now 27 can be written as 9 multiplied by 3 q cube, that is equals to 9 multiplied by 3 q cube plus 9 multiplied by 6 q cube q square plus 9 multiplied by 4q. Okay. So, we have left 8 here, we will put 8 here again. So, equation is same. Now, again a cube will become, taking 9 common from this, this and this, first 3 terms will be getting 3q cube plus 6q square plus 4q plus 8. Now, substituting, three q cube plus 6q cube plus 4q equals to m. What we will get? 3q square equals to 9m, 9m plus 8. So, this is our equation 5th. Now, look at this equation. This equation, when we did the cube of integer a, which we assumed as any positive integer, we did the cube of this and find that the answer is either in the form of 9m or 9m plus 1 or 9m plus 8. So, this question is proved, hence proved. Note this question. Okay, I am rubbing this one now. So, it's question of Euclid's division lemma. Now, let's have some more questions that's not based on Euclid's division lemma, because I promised you to practice your question based on different things. Insert a rational and irrational number between 2 and 3. Insert a rational and irrational number between 2 and 2.5. Okay, one rational and one irrational. Let's take this as first and second. Insert a rational and irrational number. Rational number is what? That you can write in the form of p by q, where q is not equals to 0. Okay. So, we are having a as 2 and b as 3. Now, for rational number, what I have to do? For rational number, formula is a plus b by 2, because average of two numbers always lies between the two numbers, right? We know this very well. So, we will do this like this. Okay. So, we have to insert only one number now. Okay. So, let's do it. 2 plus 3 by 2, that will become 5 by 2 and it will become eventually 2.5. Now, 2.5 is a number between 2 and 3 and it is also a rational number. It is a rational number. Okay. Why? Because we can write it in the form of p by q. Okay. Like this, 5 by 2. Right. Now, we have to put irrational number also here. So, for irrational, So for irrational number, what's your formula for irrational number? Remind this, you have studied it in class 9th. Root of a and b is the irrational number we are looking for. So value of a is what? 2 and value of b is what? 3. So root 6 is the number, is the irrational number between 2 and 3. Okay. Now let me tell you what is. Okay. Now the second one is insert a rational and irrational number between 2 and 2.5. Right. So for this part, what will we do? A equals to 2 and b equals to what? 2.5. So for rational number, we know what to do. A plus b by 2, that equals to 2 plus 2.5 by 2, that will become 4.5 by 2. Okay. So this is, we can write it like this also and can cancel out the things we know very well. Okay. It will become 9 by 4, which is a rational number and whose value lies between 2 and 2.5. Now for irrational number, that will become root of a and b. Now a is what? 2 and b is what? 2.5. It will become what? It will become root 5. So root 5 is one value. Now let's modify this question. If the question asked us like this, that insert 2 irrational number. If you have to insert 2 rational number, what will you do? You will again take average of this number and the previous number, like 2 and 9 by 4. You will take this, you will take average of these two numbers and you will be having this, and your answer will be as 2 numbers which lies between 2 and 2.5 and are rational. How will you apply this for irrational number? Now you will get irrational number as root 5, that was like 2, then root 5, then 2.5. Now you have to insert one more here. So what will you do? I am rubbing this part. I am just telling you, insert 2 rational numbers between 2 and 2.5. Okay. So our solution will start from here. For irrational number, a equals to 2 and b equals to 2.5. So this is the set. Now irrational number between what? 2 and root 5 is what? Root of AB, that will become root 2 multiplied by 5. That's what? 2 raised to power 1 by 2 multiplied by 5 raised to power 1 by 4. So root 5 and 2s to power 1 by 2 and 5s to power 1 by 4 is our final answer, isn't it? Okay, note it. So, next question is explain why 7 multiplied by 11 multiplied by 13 plus 13 and 7 multiplied by 6 multiplied by 4 multiplied by 5 multiplied by 3 multiplied by 2 multiplied by 1 plus 5 are what? Composite numbers. What? Composite numbers. What are composite numbers? I have told you, composite numbers are the numbers that have more than 2 factors, that is more than factors as 1 and itself. These are composite, these are composed of prime factors. Okay. Now, first 7 multiplied by 11 multiplied by 13 plus 13. Now, how can I rewrite it? That will be equals to, I can take 13 as common, that will be 11 multiplied by multiplied by 11, sorry, that will be 13 bracket 7 multiplied by 11 plus 1. I have taken 13 as common, so it will be like this. Okay, now 13 multiplied by 77 plus 1, this will be what? Like this. Now factorize 78. What will you get? 2, 3, 9. Okay. Now again by 3, 1 and 3, 13. So 3 into 13. So 2 into 3 into 13. So, what is composite number? In which we have more than 2 factors and we are having more than 2 factors and all are prime here. So, we have prime factorization here. So, we will call it a composite number. Now, look at the next one. Second, 7 multiplied by 6 multiplied by 4, 3, 2, 1 plus 5. Now again take 5 common, rewrite it in this way. How can we rewrite it? 42, 12 and 12 multiplied by 2 multiplied by 1 is 24 plus 5, that will be 5 multiply 42 by 24, 8, 16, 4, 8, that will be 1008. Now, you can do the prime factorization of this number. So, again like this, this is also a composite number. Okay. Now, property related to Hcf and Lcm. Okay, property related to Hcf and Hcm. What is the property related to this? We have read one property before, that was of 2 numbers A, B. Let's have 3 numbers A, B, C. Then LCM of A, B, C will be equals to A multiplied by B multiplied by C multiply by HCF of, mark here I am writing LCM and here I am taking HCF. HCF of A, B, C divide by HCF of AB multiply by HCF of BC multiply by HCF of AC, right? And HCF of ABC, now write LCM in place of HCF only. A multiply by B multiply by C multiply by LCM. LCM of what? ABC divided by LCM of AB multiply by LCM of BC multiply by LCM of AC. Okay. So, our this chapter is finished now, right? We have learned Euclid's division lemma, Euclid's division algorithm, and then the theorems based on it, and then the algorithm based on it. Then we have done some questions and some examples. We have known rational numbers and irrational numbers, and we have done a lot of practice. I hope you understood this complete chapter, and if you have any doubt, then if you have any doubt, then you can relook it. Okay, thank you.